Okay, so I just want to work some of these graphing problems. So I think the first one is f of x is equal to x cubed minus 6x squared plus 9x. And I'll just go through these one by one. So A, classify. This is a third degree polynomial or a cubic polynomial. B, the domain of all polynomials is minus infinity to infinity, defined everywhere. And behavior, the limit as x goes to infinity of f of x is also going to infinity. And really I'm using that the end behavior of odd functions look like this. So I have these two statements, and the limit as x goes to minus infinity of f of x is going to minus infinity. Okay, that this is controlled by the leading term, really. So I'm looking at just x cubed here. And so this leading term controls the behavior of this polynomial in the end behavior. D, there's no asymptotes, either vertical asymptotes or horizontal asymptotes or holes. E, intercepts, let me see, I need to set this equal to 0. I'll factor out, and this is x squared minus 6x plus 9 is 0. And what does this factor to? Minus 3 and minus 3. So I get x is 0 and 3. Okay. And if you ever study polynomials, this 0 of the polynomial is of multiplicity 2. We didn't talk about this, but you might have seen it before. So those are the intercepts. F, intervals of increasing, decreasing, max, and min. So I will go ahead and do that. I'm going to take the derivative, f prime of x. It's 3x squared minus 12x plus 9, I think. Is that right? I'm going to set this equal to 0 to find critical values. Get 3 times x squared minus 4x plus 3. So that's x minus 3 and x minus 1. Is that right? So get x is 3 and 1. Okay. And then I'm going to test this. I'm going to set up this number line. 1, 3. And really, I'm testing these intervals, right? And so I'll pick a test point. So this is like negative. I'm going to pick 0 here. I don't know why I picked anything else. And 2. What's happening? I wrote this one wrong. Look, this one should be a 3. So then this value should be a 4. Okay. Okay, and so then I plug that into the derivative. And this is where we talked about it's sometimes easiest to plug into this factored form of the derivative, because then you can just figure out what is positive and negative. So at 0 I have a negative and a negative, so this is positive. At 2 I have negative, positive, so this is negative. And at 4 I have a positive and a positive, so this is also positive. Okay, so then I'm going to write these. I'm going to find, because I have, so this is going up, down, up. So here at this, oh, it's really here, but there's a max. And here at this transition point, there's a min, is what I want to write, of 3. So I'm going to find f of 1 is equal to, let's say it's 1 minus 6 plus 9, right? So negative 5 plus 9 is 4. And f of 3 is 27 minus 54 plus 27. Is that right? Is that 0? Oh yeah, because 3 was this 0 of my original thing. Okay, awesome. Okay, so then I'm going to write these conclusions for f. So f of x is increasing on minus infinity to 1, union 3 to infinity. F of x is decreasing on 1 to 3. F of x has a local or relative max of 4 at x equal to 1. And f of x has a local min of 0 at x is equal to 3. Is this okay? Okay. So then part G is intervals of concavity. So I'm going to take the second derivative. Let me find the first derivative. So second derivative, 6x minus 12. So 6x minus 12 is 0. 12x is equal to 2. Is that what we get? Let me look at my notes. Yes? So, and again, I'm going to test 2. This really represents the interval from minus infinity to 2 and 2 to the infinity. I pick a test point. So here I'm going to pick 0. Here I'll pick 3. And I plug the test point into the second derivative. So the second derivative at 0 is negative, and at 3 it's positive. So really I have a concave down here and concave up here. And this means 2 is the point of inflection. So f of 2 I'm going to find. And that should be 8 minus 24 plus 18. Is that right? So that's 2, I think. Is that 26 minus 24? Okay. Good. Okay, so then I write this conclusion. F of x is concave down on minus infinity to 2. F of x is concave up on 2 to infinity. F of x has a point of inflection at 2, 2. Okay. GH, is there anything else that I need to know that's important about these polynomials? Like, you might check if this is like for symmetry. This one should not be symmetric, but that might be something I would think about. Either symmetric across the y-axis or symmetric across the origin, because that will make graphing easier. But otherwise, I can't think of anything else. If the graph, for example, is a trig function, you should talk about periodicity here, things like that. Scale on the x-axis and scale on the y-axis. So I use I mostly to kind of provide like a summary of what's happening, and in general I will just put down the x and y points. So for example, 2, 2 is this point of inflection, right? I had, has a max at 1, 4 and a min at 3, 0. Then I have these intercepts, which are 0, 0, and then 3, 0. This is also the intercept. I think, is that all the points that I have so far? I think so. Okay, and mostly I just look at the magnitude of these points, and they're all kind of in this -10 to 10 range, so maybe I can kind of make this graph like, but this kind of just helps me figure out how to number these x and y axes. But you should think about scale here. You can't use the same scale for every graph, right? 4. Okay. And I'm going to put these points on the graph. So 0, 0, 3, 0. 2, 2 is a point of inflection. 1, 4 is a max. So I put like a little cap there. 3, 0 is a min. This is also, if you remember, the behavior of this 0 of multiplicity, like that it will come down and touch the x-axis and go back up. Okay, and then you kind of see this, so in here, and then I might just get a couple of extra values here just to make sure my graph, so like at -1 and maybe at 4 to kind of see what's happening. So at -1, when I plug in, I get -1 minus 6 minus 9, which is 7 minus 9, negative 16, I think. And at 4, I'll get, I think, 64 minus 6 times 16. Ooh, is it 96? Possibly. Plus 36. Check this. Hold on, I'm going to get a calculator and check this real quick. Problem. So 4 cubed minus 6 times 4 squared plus 9 times 4. Oh, yeah, this is it. And the outcome is 4. So amazing. So up here, I'm going to get one more point. These just kind of tell me, so even here at -1, this tells me like I'm off the graph already, so I'm not even going to pass this kind of the line, the vertical line at 1. It's going to take a dive real fast like this. Oh, kind of not like that. But it is like taking a real nosedive right there. I'm going to have concave down in here, right? Then it changes to concave up, so I make this a U. And arrows like this, right? I'm kind of careful in my head, and you should not draw this dotted line, but do you see this line, like, right? I mean, it's going to hit the graph -1 at -16. So like this is going down really fast. So I know that this line that I have drawn to the left here isn't kind of just meandering. Okay, so I think that's problem 1. Let me know if you have questions.